Hey, Algebra 1. Guys, you are officially done with Chapter 1. We are now moving into Chapter 2, Section 1. This is titled Integers and Rational Numbers. All right, we are all going to be on page 53. All right, so everybody, textbooks need to always be open right there with you. Along with either at least a minimum of a blank sheet of paper, preferably your composition book, so you can take all of these notes down. All right, remember these notes, these video notes, this is like your golden ticket to getting Algebra 1 aced, okay? All right, so let's jump into it. Section 1, Chapter 2, we have 6 key terms. However, what I want you to know, you watch this video, you do not have to copy the last key term, which is titled conditional statement. You don't need that, all right? But there technically are 6, so really you just need the 5. All right, now the next part, this is really important conceptually, meaning understanding the concept, all right? There's really no math behind it. It's all conceptual. Got to think of it, got to understand the concept. And you'll notice I'm going to work from the bottom up. So we're going to start where it says whole number, then you follow the arrow, then we move to integer, then we move to rational number. Okay, these are the 3 categories that you have to know, and you have to be able to categorize any number given to you. Okay, so the basic definition for a whole number is it's a counting number. All right, you start at 1, you don't start at 0. So whole numbers are 1, 2, 3, 4, 5, and they go on for infinity. Okay, so that's a whole number. An integer opens up 2 more doors for you. All right, it opens up the doors for negative numbers as well as the door for 0. So you'll see the examples there for integer, -2, -1, 0, 1, 2, but it goes all the way infinity negative, 0, infinity positive. Okay, but you'll notice here we have not addressed any decimals or fractions yet. That is true. Now we move into rational. This is where we introduce your decimals, your fractions. But the key piece is that these decimals and fractions are only ones that either repeat. So that would be a decimal like 0.33333 goes on forever, or terminates. And by terminates, I mean that it just stops, like 0.5. That's it. Okay. Or 1/4, because really 1/4 is 0.25, and that's it. All right. So the examples I give here, 1/3, because it's repeating, that works as rational, or 1/4, that terminates. That means, what if it fits in a totally different category? What if you have a decimal that goes on forever and it never really repeats itself? The most popular example of this would be pi. That would be called an irrational number. Okay, and another quick way to determine if something is irrational is if you take the square root of a number and it does not work out perfectly. By perfectly, I mean square root of 4 is 2. That works out perfectly. But the square root of 5 does not. That would be an irrational number. Okay? Okay. Remember, you can go back and rewatch that whole little spiel there if you need it. All right, let's move on. This is just to help you for directions. All right, in the homework, it's going to say graph on a number line and tell which is greater. You just need to tell me which is greater. Don't need to graph it on a number line. It's going to save you time. Don't worry about that extra step. Okay, back into it. This is a concept we need to understand well here. Absolute value. Okay, absolute value. This makes any number or even a whole expression that could be in parentheses positive. All right, so anything that starts out as a negative, but then you put it inside absolute value lines. And by the way, what do I mean by that? These are absolute value lines right here. Okay, so if you put that number inside the absolute value lines, it will come out as a positive. All right, I'm going to undo those lines. We'll free up some note space here. Now, I gave you 2 examples. The other example that is important is 3 minus 5. That by itself is a -2. But you notice that -2 is still within the absolute value lines. So when it comes out, it's really a +2. Okay, so that's the key piece with absolute value, is it always makes an absolute positive. Okay, let's move into example problems here. Now the first two, we don't have directions, but the simple fact their directions are just which number is greater. Okay, which number is greater? And you don't have to do it on the number line, like the directions in the textbook will say. What is greater? Is it 2 or -5? 2. Simple enough. Great. Let's move on. 2 is the answer there. Starting out real easy with section 1. What's greater, -1 or -6? When you're working in the world of negatives, the closer you are to 0 is the bigger, greater number. So in this case, -1 is really the greater number. -1 is closer to 0. -6 is further away. Okay, let's take a look at number 3. Number 3, I kind of shortened the directions just to get right to the point here. So the first step is you need to tell me the category that every single number fits into. And there could be more than one, right? Because we have, if we go all the way up here, there are 3 categories: whole number, integer, and rational. Now, the one piece that I didn't say, and this is important to know, if you have a whole number, it automatically is an integer and a rational. So follow the arrows. If it is a whole number, follow the arrow, meaning it is an integer and it is rational. If it's only integer, well then follow the arrow. That means it is also rational. However, if it is rational, there's no arrow coming off of rational. So it's simply only rational. Okay, let's go back. All right, here we go. So 1/6. Does this work out perfectly? Well, not quite. However, is it a repeating or terminating decimal? And the answer is yes. So we're going to start to put our categories underneath it. 1/6, I'm just going to put an R, is rational. Okay, so let's make sure that we understand each time you have to put a category, always double check, does it fit into any more? And in this case, it does not, because it is only rational. Okay, it's a repeating decimal. All right, 1.75. Well, for starters, we do have a decimal, but it terminates, so it only fits into the one category of rational. And again, remember, if it's rational, it is not integer, it is not whole. Now, -2/3. Okay, again, we're looking at a fraction. This fraction does repeat, 0.6 going on forever. So this would just simply be rational. This is a nice, easy, simple example. 0 does fit into more than one category, right? Okay, 0 is going to fit in to 2 categories. 0 is an integer, and that would mean that it can also flow into being rational. Okay, so 2 categories for 0. All right, now the final piece of the direction says order it least to greatest. All right, so if you don't know what 1/6 is, you would have to work out the math for that. You could do some division, but 1/6, if you just want to know the quick decimal, is a 0.16, and then the 6 repeats. 1.75, that terminates, that's easy. And then 2/3, but negative, is going to be a 0.6, and that repeats. By the way, me putting a little line above it, that's called bar notation. Bar notation means whatever you put that line or that bar over tells me that that number repeats forever. Okay, so let's start with least. We have only one negative number, so -2/3 is our least. Then we're looking at the 1/, nope, scratch that. Missed the 0. Did not see that right there. We got 0. Now we're in the positive world. And now we have the 1 over 6 and then the 1.75. Okay, so that was least to greatest along with every category that those numbers fit into. All right, last problem here. You need to find whatever negative x is. Another way to think of that is what is the opposite of what's given. So if you say find negative x, easy way to say that is just find the opposite. What's the opposite of what's given? And then find the absolute value of x. All right, what's the opposite of negative 5? The opposite is positive 5. What's the absolute value of negative 5? That also is positive 5. So you would have to represent 2 positive 5s here because the opposite is 5. The absolute value is 5. So I need both parts. Okay? Now, what is the opposite of 9? Negative 9. That's the opposite. What is the absolute value of 9? It stays a positive 9. So if you have a positive and they say take the absolute value, it's still a positive. All right. So we have both of these answers being represented right there. All right. You guys are good. That is the end of 2.1 video notes. All right. Thank you guys. We'll see you in the next one.